Okay, to start with, memorize these powers. 2, 4, 8, 64. Do you get how this is 64, but all of them are different flavors of 64. 64 to the first, 8 to the second, 4 to the third is 64, and 2 to the sixth is 64. All of those are 64. So don't be surprised if there's a 64 on the test. And we expect you to know that not only that that's 8 squared, most of you would know that one, but not many would have known that was 4 to the third. It's just handy to know that. You can use a calculator on your test, but are you going to think to do 4 to the third? So, just wanted to show you a few of those important ones. 81 comes up on math teachers' tests a lot because it's not only 81 to the first, but 9 squared, but also 3 to the fourth. This one comes up. I want you to know it. All right, so here's where you might see it. On one of today's questions, you might have like 2 to the x is equal to 4 to the x minus 3. All right, everybody write that down. That's the new type of problem that I got to teach you how to do today. And it has to do with exponentials, of course, where there's an x in the exponent. Now I want to look at this from this perspective. What if I had just said 2 to the x is equal to 2 to the 5? I'm surprised how many kids struggle with this, but if that was true, wouldn't x have to be 5? Like if I put a 6 here, is there any way that that works? Is there any world in which that works? No, it has to be a 5. It has to be a 5. That's the only way it would work. So if you get the bases the same, then your exponents have to be equal. I'm going to say that again because that's the key. The whole thing for today is, can you get the bases the same? Because if you can, then the exponents have to be equal. So would you agree these do not have the same base? But you can get it so it is the same base if you can be smart enough to know I can replace the 4 with, put a parenthesis where it was. That's important. The parenthesis will make a difference. Put an empty parenthesis right there. And you know, there used to be a 4 there, right? So couldn't you put a 2 squared instead of a 4? Now aren't the bases the same? And if the bases are the same, the exponents have to be equal. So x has to equal all that. Now, we're not even going to do it because that one's a little bit difficult and we're not quite ready for that one yet. But the point is that blue 2 to the second. I replaced a 4 with a 2 to the second. And that made it work so that this equals that as an equation. All right. I'm going to finish that one. X equals 2. Notice there's a parenthesis wall right here. That's why I said that parenthesis is so important. It's not just 2x. It's 2x minus 6. You see how I have to distribute that out? That will come up. So x is equal to 2x from that, and also minus 6. And then you could, all of you, be able to solve this. Some people freak out right here at this step because they're like, oh, but there's nothing left on that side. Well, it's equal to 0 then. And if you'd rather not do that, you can start by adding 6 to both sides. Some people like that better, and it's legal. X plus 6 equals 2x. And then when you take away the x, you got to get rid of the smaller x, right? Then it's still something over here. It's just a 0 the other way. It's not wrong if you do it the other way. You just got to get used to having a 0 on one side. And 2x minus 1x is x. And x equals 6. Yeah, I solved it. Okay, so that's a typical question for today. Now, I want to step back and, again, make sure that you get some of the other stuff because we're coming up on a test. This is the last new stuff. Once I teach you this, then it's a review day tomorrow, and then it's a test the next day. So let's just remind you what's been going on in this class. Like, for example, before they started the video, I was talking about how Ireland has actually grown, but only a tiny bit since 1840. Like, they've just had a microscopic growth in their population. So if I wrote this and said that way back in 1840s, somewhere in there, they had a population of only 4 million after the potato famine. So I'm writing 4 million. Don't have to write this down. You can just listen for a second, which is rare. Enjoy it. And if I do this, 1 plus really small growth isn't even 1%, but this would be 1%. Let's not mess with anything smaller than 1% on a Monday. And then I go like this. Do you remember that that's the deal for it grows by 1% over this is like, X is like time? Could even put a T there for time if you want. I think you might see that on the test. They might put a T there. T for time. Okay. So you remember that deal? We started with this. We multiply by 1, it wouldn't actually do anything. But if we multiply something by bigger than 1, it'll grow a little bit. So that's the growth, and that's the time. And it's been a long time since 1840s. Okay. 1940 plus another 85 years is 185 years. Do you see how I did that? I just figured out how many years it was since 1840. All right. And again, I know my numbers are off. No numbers are ever perfect. Even the people that thought they knew the population of Ireland in 1840 were wrong. They just had the best guess. Okay. All right. Now, what if the population had actually shrunk since that time? There are places that have done that. There are places that used to have huge civilizations and they're down to 0 because their whole population was wiped out, like the Aztecs. Or I'm not a history expert, but I know there's other major ruins of cities, and then those people groups are just gone. So what does that mean? Well, maybe there was 4 million of people on the island of Atlantis or wherever, and I will 1 minus 0.07. That means 7% decay every year. Maybe their people just got sick. Maybe their people moved away. But for some reason, see, this is going down. That's another thing you have to be able to do on the test, is make it not just always grow, but sometimes decay or shrink. All right. And there's another formula that looks like this. I start with $5,000 and I go 1 plus, I'm getting 4%, but I'm doing it monthly. Does this ring a bell? And then I also put the 12 up here, and then I was usually putting Y for years, but I think your test is going to put a T there, T for time. And they give you the formula, but if they gave you this, do you get that they have given you a key piece of information there and a key piece of information there? Do you get it was growing by 4% and they were doing it monthly, 12 times a year? All right. And if I stuck an 8 right here where the T is, that means I'm doing it for 8 years. Because 8 times 12 is a lot of months, and that's what we're doing, is a whole bunch of monthly little adds to their money. We'd add to it monthly. We don't add 4% month, we added 1/12 of their interest, but we do it a whole bunch of months in a row. Okay, so there's some reminders of some things you had to do, and then there's one other topic that I really want to touch on. If I give you this, would you know if it was growth or decay? What is it? It's growth. If I had done 1/3, then what would it be? Decay. All right, so let's do the 3 one. I'm going to go back to, and actually copy this one down, please. Y equals 3 to the x, but I'm going to tweak it a little bit. I'm going to put plus 2 on the outside. Now, some people still think that that is left and right. It's not. What's that plus 2 actually going to do? It's going to move it up 2, yes. Okay. Now, if you just had to sketch this thing, would you have been able to tell if it was the red one or the green one? It's the red one, because it is growing. The green one would be for decay, like if this number had been like a fraction. Okay, so it's the red one, but it's been moved where? What's this move again? Up 2. So then do you get my dotted one here? Has been moved up, but it's the same kind of curve. All right, so if I had to actually graph this, though, you could not just sketch it like this. You'd have to move the asymptote up with it, which would for sure go up 2 spots because of that. Remember how the asymptote is just this? Y equals 2. See? The asymptote is up 2. And then I would need some points. Take a minute. and find me 3, because that's how many you have to have on the test. 3 points on this exponential. The test is on exponentials. You'll be asked to graph an exponential. Okay, try this. Find 3 points. Like stick in x is 0, stick in x is 1. Try that. Find 3 points on that graph. I see somebody grabbing a calculator, which is fine. Calculators are allowed, so that'll be just fine. Liam, I want you to actually do this. Your hand isn't moving. Makes me nervous. Done? Nice. You're just super fast. Kai, can you tell me one point that you know works?
0.
I put in a 0, and he gets it 2. I'm going to double check him. Put in a 0. 3 to the 0 power is 1. Plus 2 is 3. 0, comma 3. You told me you weren't awake this morning, so fair. It's fair. Okay. 3 to the 0, I think you in your head went, oh, that's 0. Plus 2 is 2. That's probably what you did. Oh, okay. If you did it on a calculator, you better check yourself, because what you might have done is did some kind of syntax wrong. So double check, because if you type in 3 to the 0 plus 2, it should be 3. I guarantee it. All right. Now I'm going to put in a 1. 3 to the 1 is 3. 3 plus 2, don't forget the plus 2. 3 plus 2 is 5. 1, 5. Liam, give me a point. And if you stick in 2, what'd you get? You are correct. And that's going to just off the graph, and it'll be fine on the test as long as you labeled it. So like if you actually put 2 comma 11 and it goes like over 2 and up 11, it's just off the graph, and you label it as 2 comma 11, I would totally accept that point. But if you wanted it to stay on the graph, I don't want you to be afraid of this power to the negative 1 power. It's going to come up again today. Do you remember when you put something to the negative 1, it does not make it negative? What is 3 to the negative 1? It is 1/3. And then you add 2 and you have 2 and 1/3, aka 2.3 approximately. Catch what happened there? That negative 1 power is one of the big ones today. So let's make sure you got that. If I said 8 to the negative 1 or 8 to the 0, they're weird, but you got to know what to do. What's 8 to the 0? 1. What's 8 to the negative 1? 1/8. That's going to come up a lot today. So I'm going to keep on hammering it home here. I'm going to give you this list, and you really need to understand all of these. 4 to the 3rd. I told you at the beginning of the hour who has a decent long-term memory. It's probably more like medium-term. And what? Say it. 64 is correct. And of course, you'll have a test. You'll have a calculator on the test. So you could have just done that on the test. But what's weirder is, what if I just said, I want to do some number, you didn't know what it was, to the 3rd, and it equaled 64. That's going to come up, I'm telling you. So just have it memorized that 4 to the 3rd is 64. Here's another one, 4 to the 2nd. That one should be easier. 16. 4 to the 1st? Oh, that's easy. How about 4 to the 0? 1. Now look at the pattern here. This is 1/4 as big. This is 1/4 as big. This is 1/4 as big. So when I go to 4 to the negative 1, don't be surprised that it's 1/4, because it's 1/4 as big. Math always makes sense if you look at it from the right perspective. Okay, so anything to the negative 1 power is 1 over that number. Okay, now can you do it backwards? What if I said 1/9? Yes. Yes. What if I said 1/4? 4 to the negative 1. See what I'm doing here? Now, the reason I'm doing all this work out ahead of time, it's a little bit like the Karate Kid. In that old movie, this kid is getting bullied by other kids, and he goes and works with this old legendary kung fu master guy, and he makes him wax his car, and he makes him wax and get used to moving his arms in a certain way to wax the car. And then it turns out that was actually because he was teaching him how to block, like a kick or a hand or like a punch. He was teaching him how to block by teaching him to wax in a certain way. So my point, I'm teaching you this because you need it when you have problems like this. Everybody write that problem down. You got to be able to see that 1/4 right there, we just practiced that a bunch of times in a different context. If you have a decent, this is probably short-term memory, you should know what to put there. Yes? Yeah. And don't forget that I said parentheses were a big deal in this unit. 4 to the -1. We want that parenthesis wall there to remind you that you're going to distribute when this thing comes out of there. All right, copy this one down. And the next thing I need is a power on the 4. I can't just make up a power, but there is a power on the 4. -1? No, because 4 to the -1 would be different than 4. I'm talking about the black 4. The 4 on the left side. Get my dice of destiny ready. That black 4 could be replaced with a 4 to a power. All I'm saying is that there's a 1 right here. That's all I'm saying. Why do I need that? Because once the bases are the same, the exponents are equal. How are you going to do it if there isn't any exponent? You have to have an exponent there, so you put a 1 there. And now I forgot this. That's part of my exponent. And now, do you get I can just erase those? I don't need those anymore. Because once the bases are the same, the exponents are equal. I'm going to rewrite this because it got kind of messy. -1 times x plus 2. All of a sudden I'm putting the x plus 2 in parentheses. There was a parenthesis wall there if you did it right. Then that means this has to distribute to both parts. 1 equals -1x minus 2. Because that's what -1 times the 2 is. And from here, I'm really close. Just have to add 2 to both sides. And then, how do you get a negative off of this? Can I just subtract 1? No. What could I do to get the negative off of there? Divide by -1 works. Negative times negative cancels. I could also times by -1. Either way, it's -3. I'm going to do a couple more with you. That's the only other new stuff for today. And I got a fair amount of review in there too. Why? Test isn't tomorrow, it's the next day though. All right, so here we go. 4 to the x equals 2 to the x minus 3. Typical question. You're trying to solve. Wouldn't it be nice if the bases were the same? Logan, what should I replace the 4 with?
2 squared.
Yes, and notice I'm using parentheses. Please, for your own good, use parentheses. And I hope you remember that when there's a parenthesis here, that means these are timesed. Right across a parenthesis, you times. Like if I had 12 to the second and then there was a 3 there, these powers get multiplied. That's 12 to the 6th. All right, so back to this. That's 2x. That's x minus 3. 2x equals x minus 3. It's almost like these just disappeared. Finish it. Solve the rest of it. It's 2x equals x minus 3. From there, I hope you can get the x alone. Roll. row 5, person 2. Heidi, what's the next step here? Hint, I got x's on both sides. Yes. 2x minus x. A lot of kids are actually confused by that because they're like, did the x's go away and it's just 2? No. 2x minus 1x. 2 xylophones take away 1 xylophone is 1 xylophone. And these are gone. Minus 3. 1x is the same as x, isn't it? Here we go. Raise your hand if you had -3. All right, you're getting this. Cool. Here's the weirdest, hardest guy. 16 to the x equals 1/4 to the x plus 1. It's all about getting the bases the same, but it's not like you're just going to turn 16 into 1/4. I doubt you will anyway. But what did I train you to replace the 1/4 with? Come on, somebody remember from earlier this hour. Not 4 to the second. 4 to the second is 16. 1/4 gets replaced with, right here, 4. 1/4 is 4, come on, say it, to the -1. So I'm going to replace this with parentheses. I should just erase the top and bottom here. 1/4 was in there, and I'm going to put 4 to the -1. Now I can make the bases the same. They aren't the same right now, but I can.
4 squared.
Yeah, that 16 can be replaced with a 4 squared. That is as hard as we would ever make them. But once you replaced one of the sides, it became more obvious. Oh, I can see how to make them the same. And once these are gone, I hope that becomes obvious that that's 2x. And I hope you don't fall into the trap of saying -x plus 1. It's not -x plus 1. Distribute this. It's -x minus 1. And then sometimes these easy equations fool people. Hunter, do you know the next step?
Add x to both sides.
Add x, yeah. Whenever you have variables on both sides, get rid of the smaller one. Like that. Two x plus x, 3x. Almost done. Divide by 3, divide by 3. -1/3. Raise your hand if you had -1/3. Okay, awesome. You know how to do this. Now the homework is a worksheet. I'm handing it out now. You can take your iPads and just shut them down. Unless you want to use it as a calculator, I'd be fine with that. But it's a worksheet for today. They're both being used right now. I'm sorry. There's a plug right behind the desk there. If you want to borrow my plug, I can do that. All right. So the homework is a worksheet, but you type in your worksheet into Schoology to see which ones you got right. And to get credit for it, you'll have to type it in to Schoology. So I'll do the first couple of the worksheet. I'm going to pause while I hand them out. Okay, so let's get started. We're doing the not graphing side. So number 1, the one we are doing, is 5 to the x equals 5 to the 3rd. And I hope you aren't baffled by that. Once the bases are the same, you can just get them out of there because the exponents have to be equal. Doot, doot. X equals 3. The end. It's solved for x. All right. Number 2. 10 to the 1 minus x equals 10 to the 4th. They're the same base. They're gone. 1 minus x equals 4. And if you can't solve that, I'll get you started. Then that's your problem. You need to know how to solve stuff like that. We're in Algebra 2. All right, number 3. If you want to ask me, I'll help you later, but I still don't feel like I should help the whole class to solve that. Number 3 is the first one where we actually have to make the bases the same, and that is 3 to the x equals 9, and they don't have the same base. So make it so they do. But when you get rid of the 9, immediately put an empty parenthesis. Please trust me that that will matter later. And in the parenthesis, you put what 9 is, which is 3 to the second, and put the second in the parenthesis. Because if there was something else out here, you'd want that on the other side of the parenthesis wall. So inside the parenthesis, put 3 squared. And now I know, this time the parenthesis didn't matter, but trust me, you do things so that when it does matter, you look both ways every time. Because sometimes it matters. I did that once. I was almost about to go across Highway 7 on a bike. I used to bike to school because I lived super close. And as I was biking across 7, decided to just take one last look, and there was a truck that would have killed me, for sure. He wouldn't have been able to miss me. I was about to push out. So my point is, you look both ways every time. Sometimes it actually matters. This parenthesis, do it every time. Sometimes it will matter. All right, then these are gone, and it's just x equals 2. Super easy. On to number 4. Of course, they're going to get harder, but this one still isn't that hard. 3 to the 2x minus 1 equals 27, and I said to replace that 27 with a parenthesis. And if you haven't got this one memorized, it is 3 to a power. Just think about it. It can't be 3 squared. You know that's not right. What do you think it is? 3 to the 3rd. And you'd have a calculator. You could check that. All right. And now that the bases are the same, super easy. 2x minus 1 equals 3. Okay, cool. I feel like you're getting this. Now the fraction ones are harder. But remember, if you want a fraction to flip over, like, do you get that 1/2 is sitting there? You can replace it with 2 to the negative 1. That's the one that's going to kind of come up the most. There's a 1/4 sitting there. You can replace it with 4 to the negative 1. They're the same thing. So remember that kind. That's the hardest kind. Is when there's a fraction and you got to know that it's replaced with something to the negative 1, like that. All right. Now, when you're done with this thing, I've given you like the first 4 answers. So we got 6 left. That's very doable. You're going to start the other side. It's tomorrow's homework, but you know that this is going to take, you're going to seriously finish this thing in like 5 more minutes if you really understand it. You might as well start on tomorrow's homework. Which part of tomorrow's homework is the other side. Okay? So work on the not graphing side first, and then go to the other side and start that. And that's all I got for you for today. Happy St. Patty's Day.